Mathematics. Mathematics, mathema, knowledge, study, learning, is the study of such topics as quantity, structure, space, and change. It has no generally accepted definition. Mathematicians seek and use patterns to formulate new conjectures. They resolve the truth or falsity of conjectures by mathematical proof. When mathematical structures are good models of real phenomena, mathematical reasoning can be used to provide insight or predictions about nature. Through the use of abstraction and logic, mathematics developed from counting, calculation, measurement, and the systematic study of the shapes and motions of physical objects. Practical mathematics has been a human activity from as far back as written records exist. The research required to solve mathematical problems can take years or even centuries of sustained inquiry. Rigorous arguments first appeared in Greek mathematics, most notably in Euclid's Elements, since the pioneering work of Giuseppe Peano (1858 to 1932), David Hilbert (1862 through 1943), and others on axiomatic systems in the late 19th century, it has become customary to view mathematical research as establishing truth by rigorous deduction from appropriately chosen axioms and definitions. Mathematics developed at a relatively slow pace until the Renaissance, when mathematical innovations interacting with new scientific discoveries led to a rapid increase in the rate of mathematical discovery that has continued to the present day. Mathematics is essential in many fields, including natural science, engineering, medicine, finance, and the social sciences. Applied mathematics has led to entirely new mathematical disciplines such as statistics and game theory. Mathematicians engage in pure mathematics, mathematics for its own sake, without having any application in mind, but practical applications for what began as pure mathematics are often discovered later. Areas of mathematics. Before the Renaissance, mathematics was divided into two areas: arithmetic, devoted to the manipulation of numbers, and geometry, devoted to the study of shapes. There was also some pseudoscience, such as numerology and astrology, but that were not clearly distinguished from mathematics. Around the Renaissance, two new main areas appeared. Mathematical notation led to algebra, which roughly speaking consists of the study and the manipulation of formulas. Calculus, consisting of the two subfields in infinitesimal calculus and integral calculus, is the study of continuous functions which model the typically nonlinear relationships between varying quantities variables. This division into four main areas, arithmetic, geometry, algebra, calculus, endured until the end of the 19th century. Areas such as celestial mechanics and solid mechanics were often then considered as part of mathematics, but now are considered as belonging to physics. Some subjects developed during this period predate mathematics and are divided into such areas as probability theory and combinatorics, which only later became regarded as autonomous areas. The subject of combinatorics has been studied for much of recorded history, yet did not become a separate branch of mathematics until the 17th century. At the end of the 19th century, the foundational crisis in mathematics and the resulting systematization of the axiomatic method led to an explosion of new areas of mathematics. The 2020 mathematics subject classification contains no less than 63 first-level areas. Some of these areas correspond to the older division, as is true regarding number theory, the modern name for higher arithmetic and geometry. Several other first-level areas have geometry in their names or are otherwise commonly considered part of geometry. Algebra and calculus do not appear as first-level areas but are respectively split into several first-level areas. Other first-level areas emerged during the 20th century or had not previously been considered as mathematics, such as mathematical logic and foundations. Number theory. Number theory began with the manipulation of numbers, that is, natural numbers, and later expanded to integers and rational numbers. Number theory was once called arithmetic, but nowadays this term is mostly used for numerical calculations. Number theory dates back to ancient Babylon and probably China. Two prominent early number theorists were Euclid of ancient Greece and Diophantus of Alexandria. The modern study of number theory in its abstract form is largely attributed to Pierre de Fermat and Leonhard Euler. The field came to full fruition with the contributions of Adrien Marie Legendre and Carl Friedrich Gauss. Many easily stated number problems have solutions that require sophisticated methods, often from across mathematics. A prominent example is Fermat's last theorem. This conjecture was stated in 1637 by Pierre de Fermat, but it was proved only in 1994 by Andrew Wiles, who used tools including scheme theory from algebraic geometry, category theory, and homological algebra. Another example is Goldbach's conjecture, which asserts that every even integer greater than 2 is the sum of two prime numbers. Stated in 1742 by Christian Goldbach, it remains unproven despite considerable effort. Number theory includes several sub-areas, including analytic number theory, algebraic number theory, geometry of numbers, method-oriented, Diophantine equations, and transcendence theory, problem-oriented. Geometry. Geometry is one of the oldest branches of mathematics. It started with empirical recipes concerning shapes such as lines, angles, and circles, which were developed mainly for the needs of surveying and architecture, but has since blossomed out into many other subfields. A fundamental innovation was the ancient Greeks' introduction of the concept of proofs, which required that every assertion must be proved. For example, it is not sufficient to verify by measurement that, say, two lengths are equal. Their equality must be proven via reasoning from previously accepted results, theorems, and a few basic statements. The basic statements are not subject to proof because they are self-evident postulates or are part of the definition of the subject of study, axioms. This principle, foundational for all mathematics, was first elaborated for geometry and was systematized by Euclid around 300 BC in his book Elements. The resulting Euclidean geometry is the study of shapes and their arrangements constructed from lines, planes, and circles in the Euclidean plane, plane geometry, and the three-dimensional Euclidean space. Euclidean geometry was developed without change of methods or scope until the 17th century, when René Descartes introduced what is now called Cartesian coordinates. This constituted a major change of paradigm. Instead of defining real numbers as lengths of line segments, see number line, it allowed the representation of points using their coordinates, which are numbers. Algebra and later calculus can thus be used to solve geometrical problems. Geometry was split into two subfields: synthetic geometry, which uses purely geometrical methods, and analytic geometry, which uses coordinates systematically.